The feeder server by Kocs, the crane system for container handling in feeder traffic. The growing container traffic across the globe is handled by large container vessels and container gantry cranes of correspondingly large size. Container vessels arrive at large terminals on each continent. From here, 35 to 40% of the unloaded containers are distributed to smaller ports by feeder vessels. Cranes installed in large terminals are vastly oversized for smaller feeder vessels. This requires a crane system that is perfectly suited to container handling and that meets specific requirements. High handling capacity, absolute reliability and safety, extreme efficiency. The Kocs feeder server meets these requirements. It constitutes the ideal crane system for feeder traffic. High handling capacity. The feeder server is perfectly fitted to the size of feeder vessels up to Panamax size, a decisive advantage. Lower hoisting heights and shorter ropes mean cargo can be handled much more quickly, faster than with any other system on the market. The feeder server permits a handling capacity of 40 containers per hour. This means that a large number of smaller vessels can be served within a short time span. Vessels that often only unload part of their cargo and that can then take off again quickly. This handling speed is not achieved through particularly fast movements, but by means of a sophisticated sequence of movements. This means acceleration values and speeds are optimized for the short distances typical for unloading feeder vessels. Large container gantry cranes have ropes that are unnecessarily long for feeder vessels. Consequently, the cargo swings for a long time and is harder to position. A time and energy-consuming disadvantage. The feeder server is finished handling the cargo when the large container gantry is still swinging. The rope system allows for nearly parallel rope falls between trolley and spreader. This offers perfect conditions for the electronic anti-sway provisions that form part of the crane's standard fittings. The hoisting mechanism is stationary and the trolley is self-propelled. It is very light and can be accelerated and decelerated with great precision. The trolley's light weight also reduces the strain on the feeder server's overall structure. The lighter trolley means the overall gantry also weighs less. Its bracings ensure that it is very robust and has a low swinging tendency. The feeder server's lightweight construction also facilitates the crane driver's work. The crane is not as high and the driver's cabin is closer to the load. The crane driver has a much better view of vessel and quay. The cabin is designed ergonomically. All operating instruments are within reach of the crane driver. This helps to prevent driver fatigue and ensures a continuously high level of performance. The interplay of all these factors results in a perfect sequence of precision movements. Containers are picked up quickly and positioned with high precision. Absolute reliability and safety. The feeder server is extremely reliable. It only contains high-quality European components that have been tried and tested in operation. It is designed with a priority on low maintenance requirements. This extends both the intervals between maintenance operations and the feeder server's overall lifespan. Should a power cut occur, the hoisting mechanisms can be operated via an emergency power supply. This allows for the rescue and safeguarding of the crane in emergency situations. Safety systems in all drives immediately react in hazardous situations. Overload protection systems, overspeed protection systems, and over-temperature protection prevent breakdowns and accidents. Snag load devices are also part of the feeder server's overall conception. This prevents the worst-case scenario of a crane accident occurring due to the load getting stuck inside a vessel. Safety brakes in the main hoist and the boom hoist mechanisms prevent the load and the boom from falling due to overload or over-acceleration. Anti-collision devices prevent collisions with neighboring cranes. Storm protection mechanisms prevent cranes from drifting off or tipping over in case of severe storms or typhoons. The entire crane is highly accessible. There is a passenger elevator and a stair tower at the gantry. This not only allows the crane driver to reach his workplace safely and easily, it also ensures the accessibility of the maintenance points. The feeder server has convenient maintenance platforms, stairs and ladders. Maintenance hoists and auxiliary systems support maintenance operations. Extreme efficiency. A durable, lightweight and robust crane is a sensible economic choice. The feeder server's design allows for low wheel loads, enabling the feeder server to be used on quays that can only carry limited weight and are unsuitable for large STS cranes. In addition, mobile travel mechanisms allow the crane to move towards the ship if necessary, meaning that the feeder server can be moved without rails as easily as a mobile harbour crane. Modern high-performance terminals rely less and less on diesel technology. With all-electric drive motors, renewable energy can be used. This makes harbours emission-free and resource-efficient. The feeder server is an extremely eco-friendly and resource-efficient crane. All drives are powered directly by electricity. During the lowering of the load and deceleration of the drives, energy is regained that can either be used for operating the crane or can be fed back into the power network. The feeder server only uses 1/5 of the energy that a mobile harbour crane requires. All versions of the feeder server have standardized drives and a standardized electrical system that is identical for all cranes. This saves engineering costs and reduces delivery periods. The life cycle cost diagram shows the overall cost of the feeder server as compared to a mobile harbour crane over time. This demonstrates the feeder server is a particularly sustainable investment. Summary. Modern container terminals increasingly rely on fully electric cranes. Better ecological balance and emission-free operations are important criteria when purchasing a crane for container handling in feeder traffic. With more than 30 cranes, the feeder server presents the most convincing concept that is proven during its daily operations on 4 continents around the globe.